everyone, welcome to Cerwin Vegas. I'm going to be continuing the restoration on a set of 417Rs. Now I've been working on these for a little bit now. When I got these speakers in the shop, and of course they needed new foam surround, which is very common with Cerwin Vega's woofers using the foam surround. I did do a video on that. If you haven't seen it, I'll leave a link in the description to that. Just a quick, simple kind of time lapse of me putting new foam on one of the woofers and just showing a comparison of what the original foam looked like before I did it and what it looks like after. On top of the foam needing to be done, there was many other things to look at that really needed attention on these, and a lot of it came to do with sound quality. And the potentiometers on the crossover were probably the main culprit to it, but we're also going a step above and going to recap the crossovers for these 417Rs. So, like some of Cerwin Vega's crossovers, these are a little more complicated than your average two-way or three-way speaker. There are in total 5 drivers that go into these speakers. So you have your woofer, your mid-range, you have 2 tweeters up front, which are both different. There's 2 different tweeters in the front. And then there is also a rear horn, rear reflecting driver, and it is the same as the tweeter, one of the tweeters in the front. And you have the ability on the crossover to control that separately. So when it comes to these crossovers, you have 3 potentiometers to adjust the sound to get it to sound right for your room that you have them placed in. You have mid frequency. Now this is going to obviously adjust the mid-range. You have your, it says horn on here. This is the rear reflecting driver adjustment. So this is a potentiometer that is going to adjust the rear tweeter, and then high frequency, this one adjusts both the front tweeters. Now they are 2 different tweeters, but they are both adjusted with this one potentiometer. So that's one thing we're going to dig into. Also going to be recapping the crossovers as well as new inductors and new resistors, kind of going, you know, all out on these to a point. You can spend a lot of money on crossover parts and what's a really nice sonic caps and stuff like that, and spend a pile, hundreds of dollars, even more if you really wanted to. But a person really has to think, what is the quality of the speaker that I'm working with, and is it really worth it? So in my mind, this being one of the better Cerwin Vega models, being a vintage model, late 70s, maybe into the early 80s, I'm not sure. I know like 77, 78, a lot around there was when these were available. And like most of their models, they went pretty cheap with the parts from the factory because it's an easy place to save some money. And if you think the amount of speakers they sold, it's going to save them, you know, a pretty good dollar. So I'm going to be going through this kind of, well, I'm going to go through it pretty good. I'm going to explain a couple of things, basically explain what I'm replacing them with. I'm not changing anything in these. I'm really just replacing with the same values, as close to the same values as what is out there and available for parts now. And I've been a big fan of Dayton audio capacitors for a while now. I've had really good results using a lot of the Dayton audio parts, and for the amount of money you pay for them, it's a really good upgrade. It's kind of your best bang for your buck in my mind. They do have 2 different kinds of capacitors that you can purchase from Dayton Audio. And the biggest difference is really the tolerance. A lot of the capacitors in here have, you know, a 10 or 20% tolerance for their value. Even though they do measure fairly close to what they say they are, you can get it at Dayton Audio, kind of their standard audio cap, but it is 5% tolerance for those guys. And you can also go up to their precision audio capacitors, and that's a 1% tolerance. So we're going to be trying those out for this one. We got Dayton Audio precision caps, 1% tolerance. We're going to be replacing the original ones here. There is room. It gets a little crammed in here, but let's take a closer look at these crossovers. Okay, so here we have the back of the crossover for the 417R. The electrolytic capacitor in these crossovers is a 40 microfarad, and this is the Dayton Audio polypropylene cap that I'm going to be replacing with it. So obviously you can see there is a very large difference in size. The Dayton audio cap is a lot larger, and that's what you're going to find with your film and foil type capacitors. They are going to be a lot larger. So that's when things get a little tricky for trying to place everything in here properly and still efficiently being able to wire everything properly. Here's the rest of them. Now, sometimes you're not always able to find the proper values that they use, especially when it comes to some of the vintage stuff, mainly because, I mean, it's been how many years, and just kind of the values, common values that are being used isn't always the easiest to get. But you can combine some to get the proper value. And I'm going to go through that later, because two of these, I had to get two capacitors to equal the value of one. And I will go through with how to wire those up properly to get the right value. Also, resistors I'm going to be changing as well. I don't usually do this because most likely the resistors probably aren't bad in here. There's really not a lot that can go wrong with them. But again, because we're kind of going all out, I want to go with a nice Dayton Audio 1% precision resistors, just to match the capacitors that are going in there. And then also we're going to be ditching the original inductors and making room for these air core inductors. One of these is an air core and one is a solid core. I really could keep that one, but I figured why, for the little bit of money that it cost to get the new Dayton Audio air coil inductors, why not? So to recap, these 417 are crossovers. Good luck finding schematics. I'm not saying they're not out there, but good chance they're going to be pretty difficult to find. The reason I wanted to find the schematics for these crossovers was just to get what the proper values of everything was supposed to be. Now, the resistors and capacitors, that's quite simple, pretty easy to know what the values of those are because they say it right on it. Like this guy here, this is a 5 microfarad capacitor here. So, of course, I went and got a 5 microfarad precision audio. It's a 5.1. There was no 5 available, but 0.1, not a big deal. Definitely not going to change much, not audible anyways. The biggest thing was the inductors. So with no schematics available, I came up empty looking everywhere, trying to find some. The next step is to use an LCR meter. This is not by far a very expensive one. You can definitely spend a lot more money on better ones. This guy will tell me everything I need to know about the crossover components of these speakers. So you can measure your inductance, you can measure capacitance and resistance all with this meter. So you can measure your capacitor values, your inductor values, and your resistor values, whether you want to check them to see if they're still good or not, or in this case, I just want to find out what the inductance value is of these two inductors that are in this crossover, because no schematics. Now, because I know I'm not going to be able to fit all this good stuff in here quite the same way that they did it here, mainly because of this electrolytic cap. I mean, we're definitely going to have to change some things around. So I'm basically going to be gutting this entire thing and replacing it. But first, I'm going to show you guys what I'm going to do to find out the value of those inductors. So I want to pull these off of here. So I'm going to get this guy out because we got to test it. And now because I broke the wire off here, I'm going to have to mess around with a little bit to get it out through there. So all I'm going to do, just like so. Okay, so when it comes to these inductors, to get a signal to it, I am going to have to now take off some of this red coating. If you notice this one here, no, because I broke down off the tip. So basically I want to get the red coating. Where is it? Hard to see these thin wires. I want to get the coating off of here So it's just bare wire, so that when I hook it up to my LCR meter, that I'm gonna get the proper reading. So there's nothing too complicated with that. I usually just kind of use some sandpaper and just kind of work it off of there. So now you can see I took some of that red coating off. It's a lot harder sometimes on these smaller guys. There, now you can really see where I took the red off of there, and I'm gonna have to do the same on this guy, and that's gonna be a little bit harder just because I didn't give myself much left to play with here. Okay, here we go. So now doesn't matter which way you hook it up. Make sure you get it on your, make sure I get my meter on a part that has the coating taken off. Like so. Turn my meter on. So it measures 0.451, so 0.45, and perfect. That's exactly what I ordered. So this is a 0.45 millihenry 20 gauge air core inductor. So that's essentially all I did to find my values. Obviously I have the parts ordered here, so I know what the values are. The other inductor in there is a 0.27. And that is a part of the front tweeter signal path. And yeah, so for the resistors were pretty easy because it says right on them what they are. I did, however, have to order two different ones. A 47 ohm resistor was not available through Parts Express, which is where I got all these. So I had to get a 40 and a 7. So there's also a proper way to wire these up to get 47 ohms resistance. So again, I'm using two resistors to get the value of one of the ones in the factory crossovers, just like these. I'm gonna have to wire these two together because there was no 2.5 microfarad Dayton Audio precision caps available at the time I ordered these. I can't remember if there even was a 2.5. So I went with a 1.5 and a 1. And then when you wire these together in parallel, so if they're wired such as this, and this is the easiest way, or this is the only way to get the proper value of these two. It'd be essentially the same as taking these and twisting them together. So this just makes one. It's gonna make this 1 and 1.5 microfarad cap a 2.5. Resistors are the opposite. To take a 40 ohm and a 7 ohm resistor, to put them together to get 47 ohms, they need to be wired in series. So they're gonna be like this. This is gonna give you the proper resistance, 47. If they're wired like I'm going to wire these capacitors, it's not gonna be the same. And I'll show you with my meter. Okay, so we're gonna be testing this. We're gonna be testing capacitance. I want 2.5, so we gotta be over 2, so I'll set my meter to 20. And all I'm gonna do, take these two, and together, this should give me 2.5, or pretty close, microfarads. Perfect. 2.51. That is awesome. If they are wired in series, you are not going to get the same reading. So in series, it'd be like this. And let's throw this on and see what we get. So when these are wired in series, you're going to get the capacitance of one minus the other, or close to anyways. So it comes to 0.6-ish when they're in series, and that's not what we want. We want 2.5. So these will be put in parallel in the crossover when I'm soldering everything together. Okay, now let's do, so here you can see we've got a 40 and a 7. So let's see what happens when we wire these up. Like the capacitors, hook these up in parallel. We gotta go to resistance. I'll have to go to the 200. Oh no, I'm thinking, there we go. 200 ohm, there we go. So you end up with 6 ohms when they're wired in parallel. But if we split these apart, because I'm going to be wiring them in series, which would be like so. There we get our 47 ohms. I'm going to get busy. I'm going to pull these potentiometers out, give them a good cleaning, test them all, make sure they're good. I'm not going to show that in this video because I already done that in another one. And then I'm going to be basically gutting the whole thing. I do have some things I need to replace. I'm hoping all these pots are going to be good and will be able to be cleaned and work properly after. If you can see these terminals here, these are nice banana plug terminals on these speakers they came with. If you look closely in there, this piece is kind of broken up in there. And that's something I'm gonna have to replace. And yeah, then I'm basically going to be cleaning this right out, gutting everything off of here, and start placing components the best way I can get them to fit in there and still look good and function properly and still make sense for all the wiring I have to do to solder these all together. And then it's just gonna be throw them together and then give it a test. Okay, now got all the wires for all the drivers in the speaker pre-cut, all the spade terminals soldered onto each end. Those are ready to go. I like to kind of get that done and out of the way. I did get the terminal plate all cleaned up. I straightened the fuse holder. I just gave it a little turn. This was turned about, let's say 90 degrees the other way. Just those little attention to details. So now when your fuse is in and the cap is turned and locked, the fuse is reading the proper way when you're looking at it. I did remove the speaker terminals off of the plate, and like a lot of these do on the older models, that plastic's been exposed for quite some time, and from tightening and loosening and tightening, the plastic gets really brittle and falls apart. So this is the piece that was on the inside. So I did replace it. I have replacements that line up. These are essentially the same. The only difference is I had to drill this out and kind of countersink the hole in a little bit, because if you see these terminals here, you can see this part is needs to kind of get sunk in there a little bit to kind of snug and get nice and tight in there, kind of like this. So if I hadn't have drilled that out, they would have sat up like this. So I did sink them in a bit, so it kind of has something to tighten up against when you are tightening the nuts in there. So yeah, that's all good to go. That's about as close to factory as you're gonna get. I'm gonna get some of this cleaned up first, and then get some of the old wires and stuff off of here, and then it's gonna be time to start gluing some of the stuff down, and then, well, basically just getting everything put back together.